Hello, and welcome to Backer Breaks It Down. In this episode, we are going to look at piecewise defined functions, and we are going to focus on evaluating a piecewise defined function. Okay, and so this little comic box here is illustrating a piecewise function. Okay, notice that it's made up of two pieces. One of the pieces is 2x minus 2, and it's defined for all x values less than 3. And the other piece is 2x minus 4, defined for all x values greater than or equal to 3. Okay, so one of the pieces I would use anytime I want to evaluate a function, like for instance at x is equal to negative 10, I'd want to use that first piece because that first piece, that's where negative 10 is defined. And that's the very first thing you have to think about when you evaluate a piecewise defined function is, well, which piece of the function should I use? Okay. So what is a piecewise function? Well, if it's a function that's a combination of one or more functions. The rule for a piecewise function is different for different parts or pieces of the domain. So the whole like x is less than or equal to 0, x is greater than 0, that's like where they're describing the different parts of the domain. Okay. And then, of course, you've got like the rule. They say it's different for different parts. So one of the rules is x minus 2. The other rule is 2x plus 1. Okay. And it all depends on what part of the domain you are evaluating for. That's how you determine which piece to use. So, for example 1 in your notes, this is our piecewise function. F of x is made up of 3 different pieces. So let's focus on the very first piece. So this tells us that f of x is equal to 5. And it's equal to 5 for all x values less than or equal to 0. Okay. So here in example 1, I do want to evaluate. Looks like we have 6 different evaluations to do. All right. And I would use this piece for any x values less than or equal to 0. So for instance, that first one, f of negative 3 is less than or equal to 0. So I would totally use this first piece to evaluate that. And you know what's even better about this very first piece? That there's really no work for me to do. Once I realize that the given x value falls in the domain, no calculating necessary here. The value of the function is simply 5. So f of negative 3 would be simply 5. So which other ones would I use this first piece for? Yeah, f of 0. 0 is less than or equal to 0. So that or equal to underneath the less than symbol means I would totally use this piece for f of 0. So f of 0 is also 5. Are there any others? Okay, so let's take a look at the next piece of our piecewise function. So this time we're going to focus in on the fact that f of x is equal to 2 minus x squared, and this is true for all x values where 0 is less than x is less than 5. So which of our 6 evaluations would we use this piece for? Yes, I agree. F of 2 definitely falls in between 0 and 5. So I definitely want to use that here because 2 is definitely in between 0 and 5. So I'm going to have to actually evaluate and calculate here. So I'm going to go 2 minus, and it's x squared, so that's going to be 2 squared. And then I can simply calculate this. So we're looking at 2 minus 4, and that's simply negative 2. Are there any others that I would use this second piece for? I agree. F of 0.5. 0.5 totally falls in between 0 and 5, so I should definitely use the second piece to evaluate f of 0.5. So I plug it in. I go 2 minus 0.5 squared And yeah, I probably want to use a calculator here. So I end up with 1.75. Are there any others we would use this second piece for? I agree. We are done here. So let's take a look at that third piece of our piecewise function. Our third piece says f of x is equal to 3x minus 4 for x's that are greater than or equal to 5. So we've got two more left that we haven't looked at yet. We have f of 5 and f of 7. Now f of 5 totally is part of the third piece because of that extra little or equal to underneath the greater than symbol. So I am definitely using this third piece for f of 5. And then I just need to plug it in. So I'm going to have 3 times 5 minus 4. And of course, that gives me 11. And then I'm using it for this last one as well. So 3 times 7 minus 4. So that's 21 minus 4. That gives me 17. Okay. So when we evaluate piecewise functions, we need to consider which piece of our piecewise function we are going to be plugging into. And then we simply do that and calculate. And that's how Becker breaks it down.